Okay. So today we're gonna start with one more protocol. This is the redundancy protocol. So let's say like okay, we have this kind of a scenario, okay, where this devices and devices they will be talking with the ISP or internet through this gateway. So you all, I hope you already know that what is gateway. Yes, what is gateway? Sure.
For different network to, if there is a different network and the router, we have to reach to there. So there is a gate by which we can go.
Yes, Murali.
So, so when we come to different networks to a router, we'll assign each gateway to the IP address which are given to the end device. It will transfer the packets.
What are you thinking? Yeah, what is gateway?
The gateway is the path which on single path that allow to pass through the from or communicate.
Okay. Yeah, gateway is nothing but what? It's a path through which we can able to communicate with the different network. Okay. So, what happens if this fails? What will happen if this gateway fails? What will happen? This all the local area network devices, they are not able to reach to the ISP. Am I right? Yes. So that is why we will go for what? I mean, in every network, there will be a redundancy. What do you mean by redundancy? It's a backup path where we can, or I can say it's a secondary path through which we can reach the destination. Okay. So what happens if this gateway fails, then it will go and reach the redundant router, or I can say backup router, or I can say secondary router. Okay, through which it can send its traffic towards the internet. Okay, so this is called as what? Redundancy. Okay, basically in this FHRP or the types of it, we give the redundancy for gateway. We give redundancy for what? Gateway. Okay, I can see here the FHRP, the first half redundancy protocol. It's a family of protocols used in a computer networking to provide the high availability and the redundancy for the default gateway in the network. What it is used for? It is just to give the high availability for what? The redundant gateway or a default gateway in the network. Okay, where it is going to ensure that if the primary route or a default gateway fails, then another router can seamlessly take over without disrupting the network. Okay, so what happens if you give the default gateway as a if you give the redundancy for the default gateway, then seamlessly it can able to talk with the internet without any, what do you call, without any problem. Okay, so now tell me, can we give multiple default gateways on this end devices? Can we give multiple? Can we give? Okay, even though if I taken a redundant router, okay, I have connected to the switch and even I connected to ISP. In this case, can I give multiple because as you already you can see that we have two routers here, router 1 and router 2. So both will be having their different what do you call default gateways or IP addresses. Can we give both of them at the same time to the end devices? No, no, right? Then what is the use of redundancy? Yeah, then how to solve this one? How to solve if I have to give the multiple gateways here? So for that one, what we're gonna do? We are going to create a virtual router. What we are going to do? We are going to create virtual router on both the routers here. And whatever the IP address and whatever the MAC address you are giving on that particular virtual router, so that will be given on this default gateway. I mean on this end devices as a default gateway to reach them to reach to the internet. Okay. So default gateway redundancy, like FHRP provides a virtual IP address that end devices like PCs or servers use as their default gateway. Okay. So this virtual IP address is mapped to multiple physical routers, ensuring that if one fails, another takes over. Okay. You already know that virtual never fails. Okay. That means if I'm using a IP address on the same range, okay, like here if I'm using 192.168.1.10 and here I'm using 1.20, so I can use a virtual gateway as 1.15. Okay, so that is what a virtual one, and the same will be given to all these end devices, and that never fails. Okay, and being in the same network, if this is getting failed, if this is not reachable, then it can take over to the next one. So that's what the next backup router duty is. What it has to do? It has to every time see this whether my active router is working or not. If that is not working, immediately I have to take it over as a active router, and all the traffic should go through me only. Okay, so this is how the redundancy works in the FHRP. Okay, so next, as I already said we are going to create a virtual router. So virtual router is created to represent the default gateway, and it has its own virtual MAC address and IP address as well, and that is shared among the participating physical router. Okay, we are going to configure in such a way that this 1.15, whatever we have, 192.168.1.15, that will be shared with both of the physical router. Okay, but that is actually the virtual router. Okay, we are going to say these two physical routers as that whatever the IP address I have here, that is 192.168.1.15, this is what the virtual router. Okay, so this will be helping you to redundant your gateways. Understood? So next, what will happen? Failover. If the active router goes offline due to any hardware failure or maintenance or any network issues, the FHRP ensures that the backup router is quickly take over as a new active router. So what will happen? If the router 1 is an active router in this case, okay, which is transferring every, what do you call, traffic, which is transmitting every traffic from this local area network. Okay, let's suppose something happens to this router, something happens to the interface or something cable fault will be there. Okay, then what the router 2 will do? It was a backup router. That means until this active router is working, the R2 will never do anything. R2 will never do anything. So when the duty of this R2 will starts when the active router get fails, then only this link will be forwarding this data towards the second backup router. Understood? So this is what happens in the FHRP. And to do this one, we have some three methods. I mean, three types of this FHRP. First one is a HSRP, hot standby routing protocol, and second one VRRP, and third one GLBP. And let me tell you, for CCNA, we have only HSRP. Okay, but I'll try to show you this VRRP as well, but it is not possible in the CPT. Okay, we have to use either EVNG or GNS3. Understood? So I'm gonna make these both HSRP and VRRP on GNS3 only. I'm not going to go to CPT. Okay. So in that first one, HSRP. So what I said, what is HSRP stands for? Hot Standby Router Protocol. It is a Cisco proprietary protocol. That means only works on the Cisco devices, where it uses router models like active and standby. So what will be the roles of these routers here? One will be the active, where it will be actively forwarding the whole traffic. And second one is standby. What is standby? It will be keeping an eye on this router. Which router? Active router. So once this router fails, active router fails, then I have to take it over as a new active router. Okay. So it provides an virtual IP address and MAC address to the virtual router, and the active router handles the whole traffic, and the standby router monitors what? The failure of that active router. And here no load balancing will happen. So you already know that if the two multiple paths are there, then the load balancing will comes into the act. I hope you know load balancing, right? Yes, what is load balancing? Yes, sending the same data by dividing it through some multiple paths. Okay, yeah, obviously it is going to meet the same destination, but you are sending it from different paths. This is called as what? Load balancing. Okay, so that is not possible in the HSRP. Okay, that is possible only in the GLBP, because we are going to give, we are going to connect multiple routers there. Okay, so through those multiple routers, we are going to send the data by balancing it. Okay, so load balancing is not possible here, and it uses a multicast address, that is 224.0.0.2 in version 1 and 224.0.0.102 in the version 2 of the HSRP. Okay, so it uses a port number, that is 1985. Yes, and a group virtual MAC address, this one, whatever the virtual MAC address has said, which we are giving it on a virtual router. Okay, the virtual IP address we are going to give it, and virtual MAC address, that also should be given, right? Then how the devices, they are going to understand which is the MAC address and all, where I have to reach and all. Yes, so this will be taking, the routers, virtual routers will be taking the MAC address from this pool. What is this pool? 0000.0C07. Yeah, I was talking about the MAC address. What is the MAC address? 40.0C07 AC. And whatever the XX you can see, this is called as what? Group number. I'll tell you what is group number and all. Okay. So it supports the IP version 6 by default. The HSRP supports IP version 6. And the hello timer is of 3 seconds and the hold timer is of 10 seconds. That means both the routers, they will say hello to each other for every 3 seconds. And if the router, if the active router get fails, then immediately after 10 seconds, the second backup router or standby router will take it over as what? New active router. Here in this case, only one active router and only one standby router will be there. We can't add multiple. Only one standby and only one active router should be there. Understood? So this is what about the HSRP. Next we have the second type, that is a VRRP. Okay. If we have a Cisco proprietary, then we have to have one open standard also, right? So this one VRRP, that is Virtual Router Redundancy Protocol. This is what? A open standard protocol. That means it's a multi-vendor protocol. Yes. Which is similar to HSRP, but designed for what? Interoperability between the vendors. That means it is supported on different vendors and even like Cisco and non-Cisco devices. So it uses a master and backup router. So what we had in the HSRP? It was like active and standby routers. In this VRRP, we take it as what? Master and backup. Master and backup router. Okay. And here also no load balancing will happen. Yes, as I already said you, it happens only in the GLBP. Okay. So it uses a multicast IP address, that is 224.0.0.18. Yes. And the port number it uses 112. And here also it uses a what do you call? Virtual MAC address. Yes. So that is 40.5E00.01XX. Again, what is XX? It is a group number. Okay. And it does not support IP version 6. As you have seen in the HSRP, by default, the HSRP supports IP version 6 addressing, but this virtual router redundancy protocol doesn't support the IP version 6. And here, the hello timer or a advertisement timer is just 1 second. That means every after 1 second, the router will say hello to each other. Okay. But if you go for the master down or hold on timer, okay, it will calculate. We have a what do you call a formula for here, just to find the master down. That is equals to 3 into advertisement timer plus skew timer. And to calculate the skew timer also, we have one more formula, that is 256 minus priority divided by 256. Okay. So this is the formula. You don't need to calculate anything. Okay. Routers themselves will calculate everything and they will give you the timer. Okay. Again, it will be in a seconds only. Understood? So here, one active router and one or more backup routers are allowed to connect. What you have seen in the HSRP? Only one active router and only one standby router is allowed to connect in the HSRP. But in this VRRP, one should be what? Active. And multiple router can be the backup routers. Okay. So that is about the VRRP. And third one, GLBP we have. So here the name itself will tell you what will happen. Gateway Load Balancing Protocol. So obviously the load balancing will be supported here. So this is also a Cisco proprietary protocol. That means works only on the Cisco devices. So it provides this redundancy and also allows load balancing across the multiple routers. And it distributes the traffic among the multiple routers using the virtual IP address. So here also we'll be having some roles like AVG and AVF. Okay, AVG means what? Active virtual gateway, and AVF means what? Active virtual forwarders. So AVG, it's kind of a router or gateway, I can say, where it is going to control all these AVFs, active virtual forwarders. Actually, the data will be forwarded from this forwarders, not from the gateway. So gateway will be just monitoring all of these AVFs. Okay. So the data totally distributed among these AVFs. Understood? So it uses a multicast address, that is 224.0.0.102 address, and the port number, that is 3222. 3222, which is the port number of this GLBP. And the MAC address is again 0007 B4 and access dot and 4 access. Okay, again that is a the what do you call group number. And the hello timer is of just 3 seconds. The whole timer is of 10 seconds. That means it is just like what? The HSRP. Okay, what was the hello timer in HSRP? 3 seconds. And the whole timer? Same 10 seconds. So here also it's the same. Okay. And as I already said you, like we have two modes of this router here. One is AVG, where it will control the network gateway, and AVFs. Up to 4 AVFs you can have, which will process the traffic. Okay. And up to 1024 virtual routers are allowed to create on a physical interface. How much we can create? 1024 virtual routers we can create on a single physical interface. Okay. Now we'll see the election process of this active and master and AVG. Okay. So to choose active router, first it will look for what? Highest priority value. It will look for what? Highest priority value. And if the priority value is same, it will look for what? Highest IP address. First, it will look for what? Highest priority value. And if the priority value is highest, then that will be considered as what? Active router or a master router or a AVG. Okay, so the election process is same for everywhere in HSRP, VRRP and GLBP. Okay, you can see here. To choose the master router, the first look for what? Highest priority value. Here also highest priority value. And if the priority value is getting same, then it will go look for what? Highest IP addresses. Okay, and the second best will become what? Second best will become standby or a backup. Okay. So next we'll go for So are you guys using GN3? Yes, you do? Okay, you're not using. Okay, the IP configuration is totally in front of you. Okay, So what I have done, let me check. Okay, what I have done here, a simple configuration, I'll tell you, the routing part. Okay, so this is my ISP. This is my ISP because that means what? I've created some loopback addresses on that one, loopback addresses. Okay, and they are totally unknown to this router 1 and router 2 because they are internet, connected to the internet. So I have done which routing here? If the network is unknown, if the destination network is unknown, in this case, which routing will do? Exactly, we'll do the default routing. Okay. So on both these, router 1 and router 2, I have done the default routing just to meet this ISP. Okay. And from this ISP to meet this router 1 and router 2, I have done static routing. Okay. So to learn this 2.0, okay, I'm running RIP on both these devices. Okay, so this is what the configuration is. If you want to see, I'll just show you. Go to this R1. This is what the configuration is. These are the IP addresses on 1/0 of the router 1. 1/0 is this one. Okay, where I have connected 192.168.1.1 network. Sorry, 1.0 network, and on 2/0 I connected with the 3.0 network. And if you scroll down, you can see here IP route. Okay, IP route. This is what default routing, and they have to go and meet what 192.168.1.2. Okay, and just to learn the other networks also, running the router RIP here 192.168.1.0 and 3.0. I just advertised here. Done. So this is what the configuration here I'm having on the router 1, and on the router 2 also it will be the same. If you want to check, you can check it here. Do show run. Yeah, there it is. On 1/0, I have given 192.168.2.0 network, and on 2/0, I have given 192.168.3.0 network. And here also I'm running with RIP protocol and which one? Default routing. Okay. On this one, what is that? The ISP router, I'm running a simple one, that is to show run array. You can able to see here. I'm just running with the static routing. To meet 3.0 network, I have two paths. Okay, one is on router 1 and second one is on router 2. Okay, and I have given both the next hops 1.1 and 2.1 also. Okay, and other than this, a normal configuration is there, like address IP addressing. On 1/0 I have given with the 1.0 network, and 2/0 I have given with the 2.0 network, and even I have created some loopback addresses also, just to reach it from the unknown network here. Okay, so this is what the configuration is. Really simple. Yes, and now let's go and do this. Let us start with what? The HSRP. Okay. See, whenever you are doing, configuring the HSRP, whatever the redundancy, okay, you have to see which is the which interface which is connected to what local area network. Okay, in this case, on router 1 and router 2, both the cases we have the interface called G2/0 and G2/0. So both of them, they are connected to what? Local area network. Okay, so on the same interface only you have to create the virtual router. Okay, or you have to give the configuration of this redundancy. Okay, so let's go on that one. That is interface gigabit Ethernet 2/0. Okay, on this one, whenever you are trying to configure this HSRP, okay, there's a term called, there's a word called standby. If you say standby, then the standby features will be activated and enabled. And if you are going for VRRP, then you have to say VRRP. And if you're going for the GLBP, you have to say GLBP. Okay, it only differs in what? HSRP. Instead of HSRP, you say it as a standby. Okay. The standby, if I say question mark, it is asking me for what? The first thing, group number. So it says that please give me the group number. Okay. So what is the number I can use? 0 to 255. So what is this? I'm going to give it as what? 1 here. Okay. After this, if I say question mark, it is asking me like, just give me an IP address to enable the HSRP. Okay. Just to create a virtual router, just give me one virtual IP address. Okay. So you have to give here IP address, IP 192.168.3.15. Okay. And that's it. Just say enter. Understood? So I have enabled the HSRP on the first router now. Clear? Let's go to router 2 and just do the same thing. Router 2. Interface G2/0, and here also you have to say standby 1. You have to be in the same group number. You have to be in the same group, and then give the virtual IP address, that is 192.168.3.15. Why I'm using 3.15? Because I'm using 3.10 here and I'm using 3.20 here. Whatever the number that will come in between, you can use any one, not only like 3.15, you can use any number. Okay, out of that 3 network. Understood? So you can see here, router 1, it says that I am active router now. But it says I am the active router. But I said like, which active, how the election will take place? Highest priority value. Okay. So just exit and say do show standby. What it says on gigabit Ethernet 0/1, I have been created with what? A group of what? HSRP. And what is my role? My role is what? Active router. The current role of this router 1 is what? Active router. And what is the virtual IP address? What is the virtual IP address? 192.168.3.15. Now, can you see this active virtual MAC address? Is it the same what I have said you? Yes. 40.0C07 AC01. What is this 01 I said? What is the group number? 1 is the group number. So that is the reason it is giving you the X value as what? 01. What if it was a 10? Huh? Come again? What if this group number was a 10? I hope you know that you bright minds, you know that we write this MAC address in hexadecimal number. Okay. So it will be 08, not 10. Understood? And this is what? In use. Okay. And what is the hello timer? I said 3 seconds and the whole timer is 10 seconds. And next hello will be sent in 1 second 264 milliseconds. Yes. And just remember this also. I'll tell you what is this preemption. We discussed about this preemption in OSPF. We did? Yes or no? He said no. We did, man. That guy. Preemption, DR, BDR. Remember, if the DR goes down, the preemption will not be enabled, so it has to wait for its turn. But here it is there. Okay, I'll tell you what is that. And next is active router is a local one. Okay, and standby router is who? 192.168.3.10. So what is this priority value? 100. It is a default one. You can see here priority value is by default it will be 100. Okay, let me take you to this router 2 as well. What it says, I'm a standby router. Okay, so if I say do show standby. Here it says that I'm into group 1, okay, and the state is what? Standby. And what is my virtual router's IP address? 192.168.3.15. And the same MAC address here also it is using for what? Virtual router. Okay. So it is also using the same MAC address for virtual router. And yeah, here also preemption is disabled. Yes. What is the priority value? 100. It is what I said. It's a default. But still, I said if the priority value is same, then it will go for what? Highest IP address. So which is the highest IP address? Out of 3.10 and 3.20, which is the highest IP address? 3.20. But 3.20 is what? Why is that? It says that active router is 192.168, 3.10. Being a same priority value and being what? Lowest IP address in the network. Why this router becomes standby router? Yes. Because I have enabled the HSRP initially on the first router. Okay, so that R1 involved into the HSRP first. So that's the reason by default it will become the active router. Later it comes to know that I have one more router in my topology that is having 3.10. So already election is taken place. Then what will happen? The first router R1 will become what? Same active router only, and R2 will be the same standby router only. Okay, so this is how this election works. Clear? So now what I want this always this router should be what? My active router. Always this R1 should be active router, because let's suppose here I have given this R2 will become what? The standby router. Let's suppose here I have given now it is gigabit. So I have given 10G bandwidth here. Okay, this is my active router, and here I have given what? 10G bandwidth, and here I have given just 1G bandwidth. Yes, so where I can get the higher speed? Where I can get the higher speed? On router 1 or through router 1. So that's the reason what I have decided. I decided that always this router 1 should be what? Active router. Okay, and R2 should be the standby router, because I'm getting only 2 Gbps data here, 2 Gbps bandwidth here, and here I'm getting 20 Gbps bandwidth. So that is the reason I want this particular R1 path should be active and R2 path should be standby. Okay, so for that reason, how I can decide that one? Always it should be what? The active. Okay, only once it is down, then it will go to the R2. That is obvious. How to decide? Always this router 1 should be the active router. Exactly, we have to increase the priority value than the current one. What is the current one? By default it is 100. Okay, I can give it as a 101 also. Okay, just more than this, what? The standby router. Okay, then only always this, even though election will takes place again, it will go for what? First it will look for the priority value, and then it will go for what? IP address. So that's the reason, just increase the priority value on the routers. Okay, so we have to do it on only the router 1. So let's do that. So just go to router 1 and interface G2/0. Here standby 1 priority. Okay, so current one is 100, so just make it as a 120. Okay, so enter. Done. So this is always will become what? Active router. Okay. Now let's go to the PC and check which path it is taking now. So PC and try to ping its own gateway first. What is the gateway of this one? Huh? Is it visible? What if I give the 3.10 or 3.20? Then it will not be called as what? Redundancy. Okay. So if I give 3.10, if the 3.10 fails, then that's over. This PC is not able to reach to ISP. Okay, because I have given only one gateway here. Okay, physical gateway. So instead of that, what I have to do? I have to give the virtual gateway. Okay, that's why I have given 192.168.3.15, and the same I have created on both the routers, router 1 and router 2. That's what we have seen now. Okay, so ping 192.168.3.15. Okay, it's picking. Yes, by default, the Cisco devices will send how many packets? 5 packets. Okay, let us check with the unknown numbers, loopback addresses. So 1.1.1.1. They said that I'm not singing here. Why? Because I guess this must be down. 1/0 must be down. So let us make it on. Exit interface gear greater than 1/0. So no shutdown. Yeah, it was down. Now if I say again ping, it says that I'm pinging. Okay. Now this time if I say traceroute, the same 1.1.1.1, which path it will take according to you? Which path? 3.10. Okay, and then it will reach 1.2. Okay, let's see. 3.10, and then it is reaching 1. And there it is reaching 1.1.1.1, which is there on the ISP. Okay, now let's see like what will happen if the 2.0 gets down. So let's go to this and interface G2/0 and make it shut down. Okay, that is down now. Then let me show you one message here. What it says? What it says? It changes state from standby to active. Okay, if you check it here, do show standby, it says that state is active now. Okay, even though having lesser priority value, my active router is down now. Okay, the router 2 says that my active router is down, so I'm going to take it charge as a active router. Okay, so let us check like which path this is taking now. Where it is going? 3.20 and then 2.2, and then it is reaching where? 1.1.1.1, or the loop back address I have created on the ISP route. Clear? Now I'll make this 0/2, sorry, 2/0 up. Once I make it as up, do you think it's gonna come back again? I made it as what? Up. Okay. Just wait for a second, that election process. What it says? Why it's standby? Is it having a highest priority value? Even though having the highest priority value, why it is standby?
Preemption.
Because of that preemption. Okay, so preemption is by default it is disabled in the HSRP. Okay, so let us enable that one. So interface gigabit Ethernet 0/0 and standby 1 and just say preempt. Okay, so by this I can say that preemption is enabled. So now you can see it will immediately become what? Standby to active. Did it become standby to active router? If you check the traffic where it is going through, it says that I'm going through 3.10. Where it is going through 3.10 and then it is reaching 1.2. Okay, so there it is reaching 1.1.1.1. Clear? Am I clear? Sure. So if you check it on this one also, it says that before I was active, okay, now I change it to standby because I got a highest priority value in the topology. Okay, so that's the reason he becomes what? Active router, and I'll be again the standby router. And I'll be watching him every time. Once he goes down, so I'll be taking it over as what? Active router to forward all the traffic towards the ISP. Am I clear? Yes? Okay. Online? Any doubt? Mr. Bosu and Narendra?
Preemption got enabled in only one interface, right? What about the other interface? Is that we need to enable there also?
No, don't need to, but you can. Because anyway, it got the highest priority value here, right? So immediately it will become not active.
Okay.
Okay.
Sir, I have one more doubt. Like initially, R1 itself is active and R2 was standby, even though the IP address is 3.20.
Yeah, I think that's
So
what
how the re-election will happen in that case? We didn't see that R2 was active anyhow in this topology.
come again.
So initially R1 was active and R2 was in standby itself
Yeah,
before.
it was.
Yeah, how the election can be re-election can be happened in that situation. So like,
The re-election will
because
not happen because initially if the router is elected as active router, okay, so re-election will not happen. The active router will be always active and the the standby will be always standby. So once the standby router, active router goes down, then the standby router will take it over as what active. And again, at that time, it will not change. I mean, if you don't change the priority value, every time the R2 will become what? The active router. Okay. So let's see here. Initially, what I said, if you have enabled the what do you call HSRP on router 2 first, then this could have been the active router initially. But what I have done, I just done it on the R1. Okay, so that's the reason this become active router, even though having the same priority value and less or lowest IP address. Yes. So the router 2 says that yes, already the election has been done. So the router 1 is what? The active router, and I'll be what? The standby router. And if I
so can't we do the re-election, sir, in that case?
can't we do what?
Re-election, like R2 want to become active in that. So
In that
highest
case,
IP address is 3.20, right? So
in that case,
it could
the
actually.
router 2 has to wait for it. Router 2 has to wait for until this router 1 becomes
Is
down.
it because of preemption?
Yeah,
Preemption was disabled initially. So
exactly. It's because of the preemption. Okay. Am I clear, Naren?
yes, sir.
Okay. Now the second one, that is VRRP. I hope you don't have any question in HSRP. No? Okay. So this is also same. VRRP is also same. I think I wasn't okay. Just say no standby 1. Okay. Now we'll go for VRRP. So it is exactly same what we have done in the HSRP. Okay. So what we have to do? Again, we have to go on the same interface. That is G2/0 where it is connected to the local area network. And instead of standby, we have to say it as a VRRP. Okay. Again, if I say question mark, it says that give me the group number. Okay. So I'll just give it as 1. And if I say question mark again, it will ask me for what? IP address, just to enable the virtual router redundancy protocol for IP. So here I'm going to give same 192.168.3.15. Okay, so that will be done. And let me show you one more thing. Exit okay. Interface give out the network/0. No, we are RP1. Now we can see there. Initially, what I have done, I just tried to configure this on the first one, first router. Okay, I configured it. Initially, it was backup and it turned into what? Master. Here it is. Why? Because I enabled the VRRP first on this first router, router 1. Okay. Now what I said, I just to check. Okay, I just removed the VRRP and try to do it on the second router. What it says now? Now the current master router is whom? Router 2 is the master router. And who is the backup? Router 1. Okay. So I hope Mr. Narendra, now you're clear, right? Wherever you run the router, sorry, the VRRP or standby router initially, so that will become what? The master or a active router. Okay. Even though having what? The lowest IP address or a lowest priority value or the same priority value, that will become active or a master. Okay. So in this case, I run this VRRP on the second router. So this immediately become what? Master, and router 2 becomes what? Backup router. Okay. So let's change that one by changing the priority value. Okay. What is the priority value? By default, it is a 100. Okay. You can see here. And let me show you one more thing. What is here? Preemption is by default enabled here in the VRRP. Clear? So let's change. I want this interface. Sorry, this router 1 as what? The active router or a master router. So interface G2/0. So this has to be what? VRRP1 priority value, it's 120. Okay, immediately it will become what? The master route. It says that I am the master now. Because of what? Because of the priority value. So let's check like where the data is going now. So just say ping 192.168.3.15. Let us check like whether I'm able to ping to my gateway or not. Now just try to traceroute 1.1.1.1. So where do you think where it will be going?
From R1?
3.10 and 1.2. Okay, it is going via 192.168, 3.10. That's nothing but the first router. Okay, let us make this as what? Down. Give it as a shutdown. Okay, this is down now. Huh? It says that I am the master. I mean, the second router says that I am the master router now. Okay, so let's check where this is going now. This is going 3.20 and then it is going to 2.2. Okay, so this is what the again what? VRRP. Okay, let's make this on again. So just say it as a no shutdown. So because of the preemption, it will become what? Master. It did? Yes. Okay. Now if you check it again, so it will be going to go through the 3.10 and then 1.2. Okay. Understood. So this is about the VRRP and the whole redundancy. Any doubt here? Come again? I said this is a virtual router IP address. How it works? The same I have been given on the both routers, right? I configured this on both of the routers. Okay, so you have to be what? A virtual router. On here also I have said like you have to be what? Virtual router. Okay, so being in same network, so this is in a 3.10 and this is into 3.20. Yes, in between I have taken one number that is 3.15. Yes, I said like on this R1, I'm using a redundancy with the help of this algorithm again. VRRP and standby what we use. With the help of this algorithm, I'm going to say these two routers side. I'm not going to give your interface IP address to the gateway. Okay, if the gateway, sorry, this end device, if it is having any traffic for this 3.15, you just send it towards the PC, sorry, ISP. Okay, so again, it is the virtual one. Virtual IP address and even the MAC address also it is given with. So completely I can take it as what? A virtual router. Understood? So what it will do? What it will do? if any kind of a traffic which is coming from the 3.1 PC, okay, so obviously it is talking to whom? The different network. 1.1.1.1 means what? It's totally different network. First it will look for whom? It will look for whom? Gateway. What is the gateway I have given? 3.15 I have given. Okay, where the 3.15 is on both the routers. On the both the routers we have. Okay, but I said like through that VRRP, whatever the priority value is having the highest one, you have to go through that router. Okay, if that is down, then you have to go to the second one. Understood? So this is how the virtual router works. Am I clear? Sure. Okay.
Sir, what if G1 bar 0 goes down? The router 1 or
Yeah, that is again the what do you call advanced configuration. Here I have here. You have to track it. You can see here. If the WAN interface is down, the end users are not able to reach out to the internet. So to overcome that one, you need to track the interface. What you have to do that one? We have to give the tracking on this 0/2/0. Okay. So in this case, what I'm gonna do? I'm gonna go on this 2/0. Okay. I'm going to configure that standby 1 track faster than 0/1. That is means what? 1/0 and give the decrement value as less than that one. If I'm going to decrease it by 30, what is the current value of the active router? What is the current priority value of the active router?
120.
120. If I decrement it by 30, what will happen? It will go 90, right? Then immediately it will be what? It will be standby, and the whatever the standby router was there, that will be active. Understood, Mr. Naren?
Yes, sir. Yes.
If I'm decreasing the priority value on this router 1, if this interface goes down, what will happen? It was active router, then it is down. I said like whenever this interface goes down, immediately decrement that priority value by 30. Priority value by
Priority will be
30.
90.
Yeah, here it will be 90 and here it will be 100. So who will be the highest one? Router 2. So immediately this will become what? Active router. Am I clear?
Yes.
Okay. You can do it. Whatever the configuration I have given here, you can do if you want. And one more thing, there is also advanced configuration. Okay, like until this active router is working, what the standby router will be doing? It is totally idle. It will not be forwarding any kind of data, isn't it? Yes or no? What the router 2 will be doing? It will be waiting for its turn. So every time the router 2 is running, every time the traffic is going through the router 1 only, then what is the use of this router 2? We can use that one also. How? By creating one more group. One more what? Group. Okay. And in that group, I'm going to make this router 2 as what? Active. And router 2 as what? Sorry, router 1 as what? Standby. But this kind of load balancing will not work much. Okay. But this is one possibility we can do. Yes. Because I already said you HSRP and VRRP doesn't support what? Load balancing. Okay. Yeah, this is what about the redundancy.
Sir, this part will be covered in routing or in switching in advance?
Advanced is routing. The ARP and ICMP is not yet done, right? I think I almost covered this ARP, how it behaves in switch, how it behaves in hub. Yes, I did. Don't worry, we'll cover everything. Yes, what is ARP?
Instead of IP address, you can use the MAC address.
Instead,
No, you can give IP address with the next to the MAC.
okay. अरे भाई वही पीछे क्यों देख रहे हैं? What is ARP?
Okay.
Yes, Bharti. Okay, let me correct it. What is address resolution protocol? Yes, Jeet Shah.
To the known IP address to the MAC address.
Yes, Abhishek.
Our packet is served in this MAC address.
Hmm.
Before being the promo devices, usually we send the packets to check the
It's very simple. What is ARP? The name itself tell you. It will help you to have the address of what? Physical address. Okay. So it is mapping of known IP address to the MAC addresses. Okay. Can see here ARP. It is a network protocol used in used to map an IP address to an physical MAC address. Okay, on a local network. So ARP is essential for what? Communication within the local area network, because devices use MAC addresses to deliver the data over the Ethernet or even the Wi-Fi. You already know that devices will use only MAC addresses just to forward the data in a local area network, not the IP address. Okay, so that is the reason, just to know what is the destination MAC address. In that case, the devices, they are going to generate one ARP packet. Okay, just to resolve the physical address there. Okay, so in that we have some different types here. I think I discussed about gracious ARP or normal ARP. Okay, we have some 5 types here. First one is a GR. Second one is what? Normal ARP. Third one, we have proxy ARP. And next we have reverse ARP. Okay. And the last one we have inverse ARP. Inverse ARP. Okay. So first one, gracious ARP. Okay, or gratuitous ARP, however you can say. So it is a special type of address resolution protocol message sent by the device to announce or update its own IP to MAC mapping to the other devices on the same network. It is mainly used for what? To find the duplicacy of the IP address in the same network. Yes. So whenever you assign an IP address to the end device or any interface, at that time, what the devices they are going to do? They are going to announce. So this is my switch. Okay, to this switch I have connected some 3 devices. Okay, so 3 devices, and when I give the IP address to the first device, that is 10.1.1.1, what it will do? It will generate one GRP packet. Okay, what will be there? It will be like source IP address, destination IP address, and then source MAC address, and after that destination MAC address. Okay, so let's say it is having AA, it is BB, and this is CC. Okay, so what will be the source MAC address? 10.1.1.1, and destination will also be the same, 10.1.1.1. Source MAC address, it is AA, and destination MAC address again 12F. 12F means what? Broadcast MAC address. So the same packet will be going to the switch. What the switch will do? It will send it to everyone. Okay. So if any other device which is being assigned with the same IP address, that is 10.1.1.1, it says that yes, I'm already having. I mean, obviously it is going to give the reply, right? So it will go and give the reply to the switch, and switch will send it towards the first PC. So it will come to know that yes, there is one more device which is assigned with the same IP address, then I have to change mine. Okay, if it will not get any kind of a reply, then it shows that it is a unique in my network. So I can assign it to me. So this is the use of what? GRP. And immediately after assigning the IP address on all the switches, on all the end devices, they will generate this GRP. Okay, just to announce that. So this is my IP address and this is my MAC address. Is there anybody who is there in my network who assigned with the same IP address? Please give me the reply. If there is not getting any reply, then it is going to keep the same IP address. Clear? Understood? So this is what about the GRPs. Next we have the normal ARP, where it's going to behave separately in both switch and a router. I hope I have shown you on switch initially when I was doing with the packet tracer introduction, right? I shown you, right? Yes or no? Don't remember? Just go to CPT. If I open the ARP table of this one, show MAC address table, is there any? Is there any MAC address? No. So once I assign the IP address, so let us go to simulation. Let me show you this too. ARP and ICMP. Okay. Once I go and assign the IP address here, IP configuration 10.1.1.1. If I say enter, immediately one packet will be generated there. Did you see? One packet is got generated there. Okay. So if I open that one, that will be the GR. Can you see that? It says that my MAC address is what? 13C1. And I'm going to announce it to everyone that I'm having the MAC IP address as what? 10.1.1.1. What is the destination MAC IP address? 10.1.1.1. So if I forward this one, the switch is going to do its job. What it's going to do? It's going to broadcast, and both the devices, they are going to deny it. Why? Because on that one, it is not yet configured to any kind of a IP address. Okay. So let's do one thing. Let's assign the IP address here first. 10.1.1.2. Okay. So let's go to the simulation and let's go to the second PC. 10.1.1.2 again. Okay, generated on ARP, GR. So it's gonna go to switch. Okay. So I'm gonna forward it. What it says? One more packet is been generated. What is that? There is what? I'm also having the same IP address. So that will be forwarded to the PC, second PC. Okay. It is denying it because here it is not yet assigned with the same IP address. You can see that it got removed. Okay. So this is the use of what? The gracious ARP, or you can say gratuitous ARP. Understood? Clear? Am I clear? So now if I say show MAC address, do you think they learned the MAC addresses? I didn't exchange any kind of traffic between these PCs. Did the switch understood the MAC address or learned the MAC address of all these? Yes or no? Yeah. Yes or no? How? It learned, but how? Because of those GR packets. Okay, it got to learn the MAC addresses of those devices. Am I clear? Okay. Now, I think they already have the, not yet, I guess. No. Okay. Now let's go to the simulation and let's check like how the ARP behaves in the switch. Okay. Let's take this EDU and this. You already know this one, right? You already know. So this is ICMP packet where it's okay. Let me write it and you also can write it down. First one is what? ICMP echo request packet. Echo request packet. Okay, so that is this one. Yes, what will be there in that one? So the same thing, what I said, source IP address, destination IP address, and source MAC address, and let's say destination MAC address. So here it will be having source MAC address as what? 10.1.1.1 and the destination is what? 10.1.1.2. Okay, so source MAC address, let's say it is having AA, this is BB, and this is CC. So here it will be having source address as AA and destination MAC address will be, it says that I don't know. I don't know what is the MAC address of the destination device. So that is the reason I'm going to call my friend, that is ARP. ARP, can you just come and help me to find the MAC address? ARP says is, yeah, that's what my duty is. That's what my job is. So for that, you have to give me some information. What is the information? So it's gonna generate one what? ARP request packet. ARP request packet. So what will be there? It's gonna take the same information from the ICMP echo request packet. That is source IP address 10.1.1.1. Okay, and destination IP address 10.1.1.2. Okay, and source MAC address AA. Okay, and this is what it got from the ICMP echo request packet. Now the destination MAC address will be what? Yes, I'm going to have your message. I mean, it will say to the ICMP. Okay, and it says that I'm going to send it to everyone. I don't know, whoever there is a 10.1.1.2, they are going to give me the reply, and the same reply I'm going to give it to you. Okay, so in that case, it's going to give it to what? 12 laps. Done. This is what? ARP request packet. Once it goes to the PC here. Okay. So let's forward this. It goes to the switch. Switch, what it will do? It will broadcast it. You can see here. It is sending it to /2 and /3. Okay. So close this one and forward this. It went to this and this. So now it is generating one ARP reply packet. You can see here, it is giving its own MAC address as source and the same 13C1 as what? The destination MAC address. Okay. So in this case, I'm gonna write it as what? The ARP reply packet. ARP reply packet. So here it will be source IP address, destination IP address, and source MAC address and the destination MAC address. Clear? After this, source will be like 10.1.1.2. Destination will be 10.1.1.1. This is where it got from the request packet. Yes, and source MAC address will be CC and destination will be AA. Okay, once this comes and reaches this ICMP, you can see here, So it's going to reply back to the switch, and what the switch will do? It's going to broadcast it again. No, right? It's going to unicast it because it already know. Switch already know that where is this A is connected. A is connected on fast Ethernet 0/1. Okay, I have to send it only to the fast Ethernet 0/1 instead of to everyone. Okay, it sent only to the fast Ethernet 0/1. Now this ARP helped his friend. Yes, this is your MAC address, what you are finding. Okay, so just take this one and just talk to your friend. Now my job is done. Okay, so it goes there. Okay, where it will be having now, instead of this 000, it will be having the MAC address. MAC address is what? C. Okay, when it comes and reaches the, I'll just forward this ICMP packet goes to the switch, and the switch is going to just unicast to the what? PC3. That is nothing but the /3. So against this echo request packet, the PC3 is going to give the ICMP echo reply packet. Echo reply packet. And the same information will be there in echo reply packet also. Okay, same information means what? Source IP address will be 10.1.1.2 and destination will be 1.1, and source MAC address will be CC and the destination MAC address will be AA. So that means yes, we both are able to talk with each other. So the ICMP echo reply packet goes to the switch, and from there it goes to the PC1. Okay, now both are pinging with each other. Okay, so this is how the switch resolves the IP to MAC addresses. Am I clear? Am I clear? Okay. Now, let's see how exactly this works in the router. So let's take a router. Does it have any MAC address? Does this? Now let us assign the IP address on the devices. So I have to give the gateway here because it has to talk with the other network. Okay, because I'm using a router here. Okay, so go to desktop and give the IP address 20.1.1.1. Okay, now do you think the switches will be having the IP addresses? Sorry, MAC addresses? Why no? GR pen. Let's go to router and assign the IP address. On this 0/0, I'm gonna assign 10.1.1.10, and on 0/2, sorry, 0/1, I'm gonna assign 20.1.1.10. So let's go to CLI and enable config interface gigabit 0/0, and the IP address will be 10.1.1.10 with 255 0.0.0.0. Just say no shut down. Exit. Interface KW0/1. The IP address will be no shutdown. Done. Exit. Let's go to simulation and just take a packet. Obviously, it's going to generate 2 packets, but there's a twist. Okay. If I open this packet, where it is going? What's the source? 10.1.1.1. That's the first PC, and destination 20.1.1.1. That's the second PC, which is into different network. Okay. And it says that I don't know what is the MAC address of that 20.1.1.1. So that's the reason I'm going to generate one ARP packet. Okay. But if you see here, ARP packet is generated for whom? ARP packet is generated for whom? 10.1.1.10. Is it for 20.1.1.1? No, it is for its own gateway. What the PC will do, it will find the destination IP address as what? 20.1.1.1. So it is totally different network. It will check its own. It will check its own. Mine is what? I'm into 10 network. Am I pinging the same 10 network? No. I'm pinging different network. Then I have to reach whom? I have to reach my default gateway. Okay, but still I don't know what is the default gateway's MAC address. So that's the reason it will generate one ARP packet for default gateway first. Okay, so when I forward this one, it goes to the PC, sorry, the switch. Okay, what the switch is going to do? It's going to broadcast. Okay, so to broadcast, it is having only one interface. Okay, it's going to go to this router now. Okay, if I open this packet, router says that I have got this request 98C1, that is actually the PC's MAC address. It came from 10.1.1 from me. Okay, and I'll be giving my MAC address as what? Destination source 5001, and which will be given to the 98C1. So do you think it's gonna go to the 20 dot network, or it will be in the same network? It will be in the same network, or it will go to the 20 network? The packet. Sure, it has to be the same because the request came from the 10.1.1.1, and to the same it is going to reply. Okay, so now it got the ICMP, the MAC address. You can see here. It says that I just want to reach 5.0.0.1 to reach what? 20. Okay, so let's forward this one. Let's go to router, but router is going to drop this one. Why? Why it's going to drop? Because router also says that I also don't know who is 20.1.1.1. For that, it will generate one more ARP packet. You can see here. Can you see? One more ARP packet is generated. Can you see that? Okay. So just open that one. What it says? I also don't know who is 20.1.1.1. So let me check who is 20.1.1.1. Okay. For that, 5.0.0.2 is means what? Sorry, 5002 is a MAC address of the second interface, that is gigabit Ethernet 0/1. Can you see that? 5002, the second one. Okay, it's a MAC address of that one. So let's open this packet again. So it is going to whom? Did I say ping from router to 20.1.1.1? No, I said it from PC, first PC, but this router is giving it different. Okay, so it will go to the PC, sorry, switch, and then it will go to the PC, and PC is going to reply back with a ARP reply packet. So by that, it is going to learn the MAC address. Now learn the router learned the MAC address. So let us open this router. Do show ARP. There you go. This is the ARP table of the router. On 0/0, it is having two entries. Two entries of what? One is of PC and one is its own interface MAC address. And on 0/1 also it has two entries. One is of PCs and second one is of its own interface MAC address. Clear? Now if I try to ping, yes, Naren? Naren, do you have any question? Okay. Now what I'll do, I'll just take one more packet here and ping. Okay. Now this time it generated only one packet. What is that? It is ICMP packet. Okay. But what it says? 10.1.1.10 and destination is what? 20.1.1.1. Oh, what is the MAC address is giving? 5001. Is it the MAC address of 20.1.1.1? No. Okay. So that's what one more ARP type comes into the act. That is a proxy ARP. Okay. What is a proxy ARP? You can see here, it is a technique in networking where one device, usually router or a gateway, responds to a ARP request on behalf of the another device. So what's happening here? Same thing is happening here, right? Router or a gateway is replying as if it is a PC2, that is 20.1.1.1. Okay, so this mechanism allows devices in different network or subnet to communicate with each other as if they are on the same subnet, but usually they will not be. Okay, this is called as what? Proxy ARP. Instead of giving the exact MAC address of the destination device, the router will give its own MAC address as if it is a destination device's MAC address. Clear? Understood? So let's forward this packet. So it goes to the router and router will change it. Okay. Yeah, still the packet will be coming from 10.1.1.1 and going to 20.1.1.1. But you can see here, now the source MAC address got changed. Here it was something different. 98C1 was the source MAC address and destination was 5.0.0.5001. Now it changed it. Now source MAC address become what? 5002 and destination become what? 60C6, which is the MAC address of the PC2. Okay. So let's forward this. It will go to the PC and PC will give its own MAC address to source. What? Source C0C and 5002. It is replying back to its own gateway, not to the PC device. Okay. Go to router. Router is going to change it again because it is having its own ARP table. Okay. By that it is going to change it. Yes. Now source become what? 5001 and destination become what? 98C1. Okay. Let's go to the PC. Clear? Everyone clear? Okay. And next one more we have, that is a reverse ARP. What is reverse ARP? It is a network protocol used to map physical MAC address to an IP addresses. What you did in a normal ARP? What you did in normal ARP? It was totally different. A known IP address was seeking for what? MAC address. So here in reverse ARP, known MAC address is seeking for what? IP address. So where you can find this kind of thing? In DHCP, or even you can say a boot P. Okay, so both will be doing what? The same MAC to IP mapping. Okay, what do you find in the DHCP, Dynamic Host Control Configuration Protocol? Your PC will be seeking for what? IP address. Your MAC address will be known, but for that MAC address, you will be seeking for the IP address. So this is what reverse ARP. So this reverse ARP is totally replaced by these two, DSCP and the bootp. Okay. So it performs the reverse function of the standard address resolution protocol, which resolves an IP address to a MAC address. Okay. So this was about the ARP. Understood? And inverse ARP, I said, inverse ARP was used in the ATM. I mean, before MPLS and SD-WAN, we used to use this ATM or frame relay in WANs. Frame relay in wide area network. Okay, just to connect to the ISP or internet. Okay, these two are the layer 2 protocols. Understood? So here, layer 2 means obviously they are going to go forward. They will be knowing the MAC address, but they want to know what? IP address. So in this case, the inverse ARP used to use. Inverse ARP, where it wanted to know MAC address to the IP address. Okay, this is called as what? Inverse ARP. And next is ICMP. We'll just discuss it tomorrow. Okay. Yeah, Mr. Bosu, Narendra, any doubt here?
Yes, sir. No, sir, I'm good.
Fine.
Okay, then we'll meet tomorrow at the same time again. Okay, till then, everybody take care and have a good day.